All right, just to catch y'all up, we had our definitions above. We taped this in, and we skipped 4 lines for ourselves to draw the top of this shape, this corner right here, and we're sketching this shape. We said the height of the shape is 6 squares, and so we drew up and down 6, and that's where we're at right now. We're going to continue sketching the shape from here. How far to the right does it go from that point? .25 is 9. 9 squares, absolutely. So we're going to go to the right 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Make sure you're sketching this in pencil. I'm doing this in pen because it shows up better on the projector. But I always like to go back and check to make sure I counted right, especially when I do it in pen because I can't erase my work. 2, 4, 6, 8, 9. Good. And then it goes up, although it doesn't say how much it goes up. There's a way to deduce it because of math. But let's go back over here just to double check our math. How far to the right does it go from this beginning corner that we started at? No. 3 squares to the right because it says 0.75. So we'll go 1, 2, 3. Then we go down 0.75, which is also 3. Now, we just go to the right where the last one ended, which should be 6, because look, 3 plus 6 equals 9. Math even works when we're sketching an oblique. That's awesome. So we're going to go 1, 2, 3, 4, 5, and 6. And again, the total height was 6. 3 plus 1, 2, 3 is 6. And so now we've sketched this front face right here in oblique. The only thing missing are these 2 side faces and these 2 top faces. We need depth to sketch that. And so let's start from this top corner right here. How far back does it go from there? 1.5, which is 6 squares. But this is cabinet oblique, right? Let me check my math, make sure I'm using cabinet oblique. Yes, that is correct. Making sure I'm using the right term. Sometimes I get them confused. So what would be our depth in actuality? We're going to go back 3 diagonals. Absolutely. 1, 2, 3. What about from this corner? How far back will we go? It's also a depth of 6. So yes, we'll go back 3 diagonals. 1, 2, 3. Now, if you did it right, this should still be a width of 3. We should be able to go from left to right from this back edge. 1, 2, 3. And it should work again because math. And if you look, yes, that was a length of 3 squares. Now, how far down does it go from here? 1, 2, 3. Now, you might be thinking divide this by 2. This is a height. You only divide your depths by 2. It doesn't matter that we're in the back. This is still up and down. So you draw your widths and your heights in full scale, whether you're drawing them in the front or the back. It's the depth that's divided by 2. The depth is 6, as we've said. So that means work should be separated by a diagonal of 3. 1, 2, 3. And it works out again because math. Now we go to the right again, just like we did here. 6, 1, 2, 3, 4, 5, and 6. And again, if you did it right, it should be separated by a depth of 3 diagonals, which of course means 6 in oblique cabinet sketching. 1, 2, 3. Then this goes diagonal 3 as well. 1, 2, 3. And then we got this height separated by 3 as well, again, because math. And it all works out. It is easy. It's just like isometric paper. The only difference is width goes left and right, and depth goes diagonal cut in half. Pretty sure we wrote that down somewhere. Okay. Now let's sketch this shape. Now, you got to make sure you have enough room for yourself. So I'm going to go to the right. I'm going to start this corner myself. Maybe about right here for myself. So that'll be the far left edge. Let me mark that in blue, actually, so you can see it right here. But again, I have plenty of room above. I can tell I have at least 3 squares above, which I need. But I also need 6 squares below that corner. If you do not have 6 squares above it, you either need to move it around and find a more strategic place for it, or go to the next page. You need 3 above for the depth, right? You need to go 3 diagonals back. We will do that in a second. Do you see that? Good question. Thank you for asking. Anybody else need me to repeat these directions? Good. From here, from this corner, how far down does it go? 1.5 is 6 squares. Yes, we'll go 1, 2, 3, 4, 5, and 6. I like to double check my math. 2, 4, 6. Good. And then it goes to the right. How many from there? 1.25 is 5. And remember, this is full scale because this is a width. So we'll go to the right. 1, 2, 3, 4, 5. And then some weird stuff happens in the depth direction for us. Let's worry about that in a second. Let's go back up here to this blue dot at the beginning. How far to the right did it go from there? 3. It was exactly like this one on this side of the shape. It was exactly like the one we drew before. It's not until we get down here where it starts changing a little bit. So let's go to the right. 1, 2, 3. The height is also 3, so we'll go down 1, 2, 3. Now, if this entire width is 5 and this width is 3, what does this little width have to be to equal 5? 2, because math. 1, 2. Again, 2 plus 3 is 5. Math even works with lines and oblique sketch. And let me move this over to the center so you can see this better in the video. And then we go down 1, 2, 3, because again, 3 plus 3 is a total height of 6. Now, looking here, this is a depth. The question is how far back does it go? Well, what is the total depth? 1.5, which is 6 squares. What is this depth right here? Which is 4 squares. Yes, this one represents 4 squares. So what does this have to be? 2, because 2 plus 4 is 6. But here's the deal. That is a diagonal direction. So how many diagonals will we go back from this corner? 1 diagonal back. We will do that here and here. Does everybody see how we figured that out? Now, the height should still be 3. That hasn't changed. Just because we're at the back, or I'm sorry, the middle of the shape, we're not at the front anymore, doesn't mean it magically got shorter. It should still be 3. And if you did it right, these 2 corners should be separated by a length of 3. Now, we got to do some more math again. We got to go to the right. The question is how far to the right? Well, if the total the total width is 9, that's what 2.25 is, and this length was 5, what does the rest of the width have to be? 4, because math. 4 plus 5 is 9. So we go 1, 2, 3, 4. Then the height is still 3. That still hasn't changed just because we're at the right side of the shape. And again, if we did it right, these should be separated by a length of 4 as well. Now, earlier we said this depth was 4 squares, which is how many diagonals? 2. 1, 2. Now, do y'all see how I'm getting pretty close to the edge of the page? We cut that pretty close. You don't want to go off the page for obvious reasons. If you do, you have to erase and resketch it somewhere else. This is also a depth of 2 diagonals, which is 4 squares. And then if we did it right, the total height should be 1, 2, 3. Now, what's awesome here is even though it went back and then to the right and back again, our total depth still works out. What is the total depth again? What is the total depth again? 6. So from this corner, that's 3 diagonals. 1, 2, 3. What's cool is this is 2, as we said earlier. This is 4, so this total line should be 6. This whole line should be 6 long. And if you did it right, these 2 corners should be 6 apart from each other. 1, 2, 3, 4, 5, and 6. And so it is true. Math always works. If you find yourself where math isn't working, you're either in the wrong universe or you're doing it wrong. And those are pretty much the only options. What is this height again? 3. So it's going to continue being 3 in the back. 1, 2, 3. And if you did it right, that should be separated by a depth of 3 diagonals or 6 squares because the total depth hasn't changed. We go to the left. How many? 3 more. And again, if you did it right, a depth of 3 diagonals, which is again 6 squares in cabinet oblique sketching. And then we finished these first 2 shapes.